Good morning everyone. Welcome to One Concept Per Day portal, and this question is taken from May 2006 TZ1 paper. Okay. Um, okay. The concept that we are discussing today is on specific heat related to another chapter, which is about the electric current, power, voltage, temperature, and so on. In the previous two videos, we have already seen about how specific heat and latent heat can be calculated using graphs. And in the first video, we had seen about how to define specific heat and what happens when temperatures increase, what happens to specific heat, and why there are two different specific heats for a gas, okay, namely specific heat at pressure, constant volume, and so on. Okay, now let us start with the current example. Right. The drawing below shows part of the heating circuit of a domestic shower, and insulated wire 240 volt supply water pipe is shown over here. This is a water pipe, and there's a insulated heating element. Okay, so and then cold water comes inside this over here and goes out at hot at 40 degrees centigrade. Okay, that's what is shown. The heating element is rated 7.2 kilowatt and 240 watt. Okay, so what does this give? This gives me the power, and this gives me the voltage at which it has been operated. The water enters at temperature of 14 degrees centigrade and leaves at temperature of 40 degrees centigrade. Specific heat capacity is given over here. There are two temperatures, T1 and T2. Do not immediately rush and say, okay, I'm going to calculate EBE equal to MC delta Q. Just wait for a moment, read the question. So whenever there is a T1 and T2 given, that doesn't mean that you should always calculate MC delta T. Okay, keep this in mind. So describe how thermal energy is transferred from heating element to the water. How is the thermal energy transferred? What has been happening? So current now passes through this one here, and as a result of this, okay, the insulated heating element gets heated and the energy is transferred to the water. Now we need to describe the process what's happening over here. So what are the different processes in which the water can get heated? First one is there can be a conduction, right? So heating element, let us write down, heating element transfers energy through conduction. Because this was 3 marks, I need to write something on 3 marks. The second one, then convection of water molecules. What happens about the convection of water molecules? There is a water bubble created, and the water bubble slowly goes upwards, right? And thus it transfers the heat to all the water molecules. Takes place to transfer the heat, because the interest here is only to understand what are the different methods of heat transfer that's happening over here. How is the heat energy transfer happening? That's what has been asked. Then third, I need one more point. See, as the element gets heated up, there's a possibility that every element will now start radiating, right? Even I will be radiating heat energy. Okay? Because if you take an IR camera and take a picture of me, you can see some regions of me are seen to be reddish in color, some of them are bluish in color, and so on, which tells you that part of it, the heat is being given out, right? So therefore, you can say the heating element also radiates heat energy, and this energy is transferred to water molecules. Right? Thus you can mention all the three different methods of the heat energy transfer that's been taking place. Okay, next question. What is the next question over here? Estimate the flow rate in kg per second of the water. Okay, once again I'm telling you, do not directly find out what is MC delta T here. Now, flow rate. What do you mean by flow rate? Flow rate, and look at the unit over here. If you do not understand what is this one here, look at the units over here. Always in any physics problem, if you do not understand the term, then what to do is look at the unit. The unit is kg per second, which means what? Kg is mass and time is t over here. Somewhere you should determine this value. Now how do you determine this? What you do is, now let us write down that E is equal to mc delta t. E equal to mc delta t. Now you will see I got m here, but I don't have a time here. If I divide this by time, what do I get? I get something like this, which I can write this as m by t into C delta T. Now what is E by T? E by T is power. The power should be equal to M by T into C into delta T. Now let us understand whether all these terms are given. Say if P, C, delta T is given, then easily you can do it. Let us see what is P here. Is power given? Power is already given, 7.2 kilowatt. Wonderful. So I can now substitute this. I can write 7.2 into 10 cube is equal to M by T is what we need to determine. I'll just write M by T here into, is the specific heat given? Obviously, we have seen this 4.2 into 10 cube is also given into 4.2 into 10 cube multiplied by C is known. Now delta T, see, as you guessed it across, 40 minus 14 should be your delta T. Let us substitute that also. This should be 40 minus 14. Now let us substitute all this and get the final answer. So your M by T should now be equal to, you see, this 10 cube and 10 cube goes away here. I'll write this as 7.2 divided by 4.2 multiplied by 40 minus 40 is 26. So when I do this, let me take my calculator. Calculator always blocks my content. Okay. So now this is 7.2 divided by 4.2 is equal to so much divided by 26 is equal to 0.06593. I'll make it a 0.066. 0.066 unit is kg per second. Okay. Thus we have come to how to solve this particular problem. It gives you 4 marks. Then suggest 2 reasons why your answer to B is only an estimate. What is the reason? Okay, now let us read the problem, only then we'll understand what is the estimate over here. Diagram shows part of the heating circuit of a domestic shower. Okay. Water is now moving like this. Has it been given that the water pipe is insulated over here? There's an insulated wire to carry the electric current. But what about this? Nothing is shown, right? So there is a possibility that energy can be lost. There's one possibility which is possible. Then what is the other possibility? Let us look at that. And then it says that, okay, so something like this, water enters the floor and then it moves across over here. Okay, let me do this also. Okay, now it says about all this energy is lost is one reason. And then the flow rate that we have mentioned, let us come back to this one here. This M by T is equal to 0.066 kg. This may not be a constant. Why this may not be a constant? If you ask me this question, if you look at this, M by T is equal to P divided by C delta T. M by T is directly proportional to P over here. If it is proportional to P, what is P here? P is nothing but energy multiplied by time. Okay. How do you get that energy? Which energy are we talking about? The energy that we are talking about is nothing but the electrical energy. Do you think the electrical energy would be supplied constantly? Not required, right? Sometimes there could be a voltage fluctuations. Okay, that will be 240 volts may not be constant. You might get 240, sometimes 180, sometimes 270. It can be fluctuating over here. So you can mention that over here, right? So therefore, you can mention energy can be lost to the surroundings is one of them. Then electrical energy supplied may vary due to swing, you can say, or due to temperature changes, because as time progresses, temperature will increase. When temperature increases, what happens? Resistance changes, right? Resistance changes can happen, and as a result of it, current can change, or there could be some amount of voltage drop in the internal resistance. Anything can change, right? Okay. Then next one. Calculate the current in the heating element when the element is operated at 7.2 kilowatt. So we are asking you to find out the current over here. So power is given over here. So how do you find? Very easy. P is equal to V into I, right? So V should be equal to P divided by, what is that I need? I need the I over here. I'm sorry. Put I here. I should be equal to P by V. I should be equal to P by V. What is P? 7.2 into 10 cube. And what is the value of V? See, value of V is already given in the diagram itself. It was given. See, it's 240 volt. So I'll substitute this value here. I'll substitute this as 240, which should now be equal to, we take this value, 7.2 7.2 into 1000 is 7,200. 7,200 divided by 240 will give me 30 volts, 30 amperes. Sorry. 30 amperes. This is the amount of current taken. Explain why the shower unit is switched on. The initial current of the heating element is greater than the current calculated in D. Which means what? Before you switched it on, okay, or maybe the moment you switch it on, and let us say there is an ammeter over there, it will not be showing 30 amperes. It may be showing 35 amperes. Okay, that is seen to be true. Now, why is this? Okay, the simplest answer is that, okay, when this for 2 marks, when the element is switched on, what's happening? Switched on. Now let us look at what do we do when element is switched on. It's a cold water at 14 degrees centigrade. Which means what? This is now at a lower temperature, right? Okay, let us see that. Let us write it down. The element is at lower temperature. When it is at lower temperature, what do you mean by that? That means it has a lower resistance. If it is at lower resistance, what will happen? Then it has a higher current. So as a result of this current, okay, at t equal to 0 can be greater than this current at any instant of time t, right? Therefore, this is what you need to put it across. Okay, now let us move on to the next question. In some countries, shower units are operated from a 110 volt supply. Okay, a heating element operates with 240 volt supply with a resistance R240 and an element operates from 110 volt supply with a resistance R110. Okay, deduce that for heating elements to have identical power outputs. See, every phrase has a meaning. Identical power outputs. It means that somewhere is equating the power. Okay, there should be two circumstances, two criteria, and each of them should be equal. The power should be equal in both the criteria. So what are those? See, for R110 and R240, the power should be equal. Now somewhere you need to relate this power to the resistance over here. Which equation gives you? Okay, see, current is not shown. So see, you have 110 volt and 240 volt over here. So do not use I squared into R. P equal to I squared into R. I'm not going to use it. It's not that it's incorrect because I do not know the current. It's not better. It's better not to use this. So, but we can always use P is equal to V squared by R. Let us use this. So what I will do is I'll write R110 divided by R240 according to this equation. I'll write on here R equal to V square by P. According to this, for R110, if I write R110, I can now write this as what is the value of 110? What do you mean by 110 here? That means V is 110 here. So 110 square divided by P. And what is meant by R240? 240 means 240 square divided by P. Why am I not writing P1, P2 here? The reason is because I said that identical power outputs, right? So therefore, these P's are not going to change. Okay, it's remaining the same. So what I will do is I'll just equate this. And R110 would be 110 the whole square divided by P divided by 240 square divided by P. This P and this P goes away. And thus you have this as 11 divided by 24 the whole square. Where is the 0 going? 0, 0 cancels, right? So I cancels away. I get so much over here. Let us calculate what is this value here. So this should now be equal to 11 divided by 24, which will be 0.458. This is not the end of the answer because I need to square this. So let me square this also with the square here. Square is here, which comes out to be 0.21. Wow, this we have got the same answer. 0.21 is the answer as predicted over here. Okay. So thus we have come to question number F. We have finished this also. Using the ratio in one, explain one disadvantage of using a 110 volt supply for domestic purposes. Okay, now we need to reason using this particular equation. Let us write down that equation. So I will write R110 by R240 is equal to 0.21. What does it tell you? It means R110 is equal to 0.21 times R240. So what does it tell you? It means R110 is less than R240. Okay. Now what is he asking? Asking is that one disadvantage of using a 110 volt power supply for domestic purposes based on this. Okay. Now what we do is, if resistance is lower, that means what we mean, the current is higher. The current is higher. Okay. You learned from electromagnetic induction chapter that whenever there is a current is higher, okay, then the voltage should be lower. Okay, that's one problem. And when you transmit current from one end to the other end, definitely the transmission lines will take a large amount of electricity to it. That's one issue. Okay, I'm not going to highlight that one over here, but I will take up this example, and I will take up this example. More than this, I'll take up this value here. Whenever I say lower resistances, what does it tell you? We know that R is equal to rho L divided by A. For a given wire, okay, of a given length, okay, rho and L are same. If I want this to be rho, the lesser, if R has to be lesser, what should I do? I should increase the value of E, right? If R has to go down, then A has to go up, right? A should be higher, which means I cannot use a wire which is thinner. I have to use a wire which is thicker. Okay, I need to use a wire which is thick wire. When I use a thick wire, what are the problems? The first problem is this: it will occupy a lot amount of space. The second problem is that you are using more amount of material over here. When you use more amount of material, then what can happen? The wire will become more expensive, right? So therefore, do you think this is desirable? This is not desirable. See, I would like to design an electrical equipment so that I need to compete with my competitors and see to it that it's available at a much cheaper rate. First thing. And secondly, when the resistance is lower and the current becomes higher, there's every possibility sometimes we can burn the experiment also. Okay, so as a result of it, I don't want to have such kinds of expensive equipments, okay, and this bulkier also. So many negatives. Why should I go for this? I will never go for it. So instead of it, I will say that my operating voltage should be 240 volts, right? That's what in India we do, right? So we always have 240 volts as our main sockets. Okay, so with this, I think we have come to an end to all the three problems related to specific heat. And if you have any more questions, you can always write back to me in my YouTube channel. So before you go, please do like, share, and subscribe to my channel for most of the updates. At least by this week. This week I think I'll be able to put only 3 problems. This week also I'm quite busy with many other things. Okay, let us see how does it go. Thank you very much for patiently listening.